Hello everyone, welcome back to Practical Serverless and Microservices with C#. My name is Muhammad Abdullah and I am Microsoft Certified Azure Solution Architect. For this course, our agenda is to understand the serverless application, how serverless application work, how to deploy serverless application. We'll understand the microservices, onion architecture, different type of onion architecture like domain layer, application layer, and infrastructure layer. Then we will learn Docker and then Azure function. There are different triggers, background function, IoT function, microservices in detail, and we will see microservice organization with Kubernetes, how to use Kubernetes with microservices, and then we will learn practically container and Kubernetes and Azure Container App, and how to apply security observability for serverless and microservices application. And for this course, we will see the car sharing application microservices practically, and lastly we will see microservices with .NET Aspire. So this is our agenda. If you missed the previous lectures, please check out, and you can continue. Session number 5 is related to Docker, so we will learn about Docker. So microservices need to be independent of their host environment to enable easy load balancing and to use the hardware utilization. So we are facing one challenge, like if we are working with legacy application with newer modules, they use the different development stack that create dependency on the environment. Each stack has own requisite. So this is our challenge. To fix this challenge, the older solution is to deploy each microservices on the separate virtual machine. So this is the old solution, but here is one problem with this solution, like virtual machine are slow to start and stop. So this is the problem with my virtual machine, because they have their own copy of the operating system, which is insufficient for microservices that need to be quick, like microservices need to be quickly start. So this is the one problem with virtual machine. So we can fix with this problem with the container solution. Like container is lightweight and efficient form of the virtualization. So in this video we'll see the container. So the container solution, how they work, like virtual machine that utilize the entire machine, including the operating system. Container utilized at the file level, and they sit on the top of the operating system kernel, and they use the host operating system like kernel DLL driver, but use its native feature to isolate processes and resources. This create an isolated environment for the application they run. So this is the how the container work. Like we will see this in the diagram, like we are comparing Docker container and virtual machine, and you can see here virtual machine have infrastructure layer, then host operating system, then the virtualization tool hypervisor, and it have like three virtual machine 1, 2, 3, and they each virtual machine have their own guest operating system. But in case of Docker, they are using the host environment, like host operating system, and they use the Docker engine, and they create a container to run different applications. So this is the main difference between container and the virtual machine. So container have what is container, like the running instance of application is called container. They are created from the images. So first we have images, then from images we create containers, multiple instances of container. And what is images? Already read-only template that contain all the necessary code, instruction, library, dependencies to run the application. The same image can be used to create multiple identical container. We can create multiple container from single image. And what is image directory? Where images are stored and managed, like you can think like a Docker hub. We can store images in Docker Hub. We can also use ACR, Azure Container Registry. So this is a type of repositories where we can save the images. And this is the naming, image naming and tagging. For example, first of all, we have, this is the example, ncr.microsoft.com. So this is the part of the domain registry, and .NET is the namespace, and ASP.NET is the repository name, and the 9.0 is the tag number. So this is the URL of the image. Whenever you need any image from any repository, you will just place this URL, you will get this URL, and you can use that image. So this is the URL of the image. And now we will discuss the container and image lifecycle. Like process, any runtime that need to create container, download the required image from our registry. So for example, if you need a .NET runtime, so you will use that you will get this from registry and you can use it. Some images required credential as well. Like there is two type of, one is public, one is the private one. Private one need the credential as well. Image to container. Once the image is downloaded, when you download the image, the runtime use it to create one or more containers. So then we can create container as many as we want. So here you can see here the instruction docker file is nothing but instruction. Then we create image from that and we save ACR or a docker hub, so we can use that, and then we can pull and we can use, and we can create containers. So here we will see the docker. What is docker? Like a de facto standard for working with containers. So we have docker file. Any runtime that need to create container, download the required image from the registry. It may need credential to access the registry. Building images. Docker images are generated by applying change. Okay, so now we'll discuss the form instruction. Like when you create a Docker file, they have the form instruction. Like Docker file usually start from a form. It specifies the base image to modify. For example, form mcr-microsoft.com/.net/sp.net and 9.0. So this is the form instruction. You will see this when we do a practical Docker file creation, and this set the build stage or the starting environment. So this is the, like your computer pull the image and it's built, and they, after building they run the container and you can see the application. So this is building. We will see this in practice as well. We will build the image. And registry URL, the full URL specify the registry domain. We already discussed how the URL look like. They have the registry domain, namespace, repository, and the tag. We already discussed. This is the example. You can use any type of registry like Docker Hub registry and is your container registry. So this is up to you where you can store the image. And we have the images in hierarchy, like the images and container in the hierarchy. First, like image 1, 2, and you can n number of images, and each image have n number of containers. So this is some of the hierarchy of the images and container. Okay, so key Docker file instruction. So when we see the Docker file, we have working directory instruction. Like we discussed the form, now we are discussing the working directory. So working directory define the current working directly inside the image file system. If the direct does not exist, it's create. So below is the command instruction, the full instruction. So yeah, so next is the copy instruction. Copy file or folder from your computer into image file system. Can copy a single file, a whole folder, and multiple file as well. Here is the command instruction. So we will see this all the command in our Docker file. And next is the run, execute a shell command inside the image. For example, run .NET restore. So this is the type of the run instruction. Next is the CMD and entry point. Specify the command in argument to be executed when a container is run for the image. So below is the CMD and entry point instruction. And next is the expose. Declare the network port that container support. It acts as a documentation. It does not block traffic to other ports, but signal which port are intended for use. So this is for port. We can use the expose. And if next we'll discuss the stages, like Docker file have sometime multi-stage build as well. So what is the concept behind this multi-stage build? A Docker file can build intermediary image to create the final smaller image. For example, create an image that contains the entire .NET SDK using form instruction. This is the build stage, for example. And then use run to compile your entire .NET solution, and create a separate final image using a different form instruction, like just the .NET runtime. So once your application is built, then you will need the runtime to run the application. So this is multi-stage build. We'll see this as well. And use copy from build to copy only the compiled binary from the build image into the final stage. So what is the benefit of this? The final image is much smaller in size because it does not include unnecessary build tool or source code, which is more secure and efficient for production level. So if you want to do a production level setup, so you can use the multiple stage build is highly recommended. So for example, I will go back to my Visual Studio. So you can see here, this is a multi-build stage. This is the base. It's create the base. So this is stage number 1, the base stage, and this is the build stage. This is the build stage, and this is the publish, and this is the final stage. So this is like multi-stage Docker file. So the only purpose is to get the smaller image. So I will go back to the slides. So okay, next is getting started Docker file. If you are new to Docker file, you can install the Docker file on your Mac machine and Windows machine. I already have downloaded. For example, what Docker file I require for using Docker on your personal computer. It include like Docker runtime to create and run the container from images, a Docker client to build images. We can run, and we can also store the images in local registry as well. And this course, assume you are using the Windows machine with WSL, Windows subscribe for Linux, install and configure for the Linux container. So I already installed WSL. For the Linux, so I will show you. For example, if I go to this is the Docker desktop application. You can see here where you can find all the running containers. So this is the one container which is currently running. When you click, you can go to the log. You can see the application is currently running. You can inspect, and this is bind mouse, execute all the execute files, and this is the file system of the image, and this is the states. So and you can also see the images, all the images volume to get the persistent state. We can use we will see this in detail, and all the builds. And this is the basic version. If you are you did not install, you can install this Docker to run the application. So let's go back to the slides. Okay, so here we will create one simple application to demonstrate how Docker can build and run a program without needing the language runtime or SDK installed on your host machine. So this is the simple. Open the Visual Studio. So I already created one simple console application. So there is nothing, just one main program. And how you will add the Docker support to this project. So here you have two options. Whenever you create new project, you will create new project. You can go with the name. You will give name. Then here you can see that framework, and you can see here enable container support. When you check this, it will add the Docker support. And here is the container OS, so you can choose the Linux and the Windows. So I will go with Linux, and here is the container build type. So I have a Docker file. I will select the Docker file, and you will click on the create. So when you create, the project will the Visual Studio will be add the Docker file in default. So but if you don't have Docker file in start, you can also add it to existing project as well. So you will click on the right click, and you will click on the add, and you will see here Docker support. So when you click on the Docker support, it will ask for a few options, like I will go with the Linux, I will go with the Docker file, not the .NET SDK. And here is the container image distro. It is the engine type, so I will go with the default one. And this is the build context. This is the path where this is the root path of my project. So I will create the Docker file in the same root level. So I will click on the OK. So you can see here one file is added, which is the Docker file, and here is the detail of the Docker. So it's a multi-stage. I already discussed the multi-stage. Why we need a multi-stage? It's for production, to get the image smaller and production ready and secure. And you can see here first it will get the .NET runtime for us, and the working directory is the current. This is the image working directory, and this is the second build stage. It will get the .NET SDK 9.0, and this working directory for this is CRS, and it will copy from this is my current project path, and from my current project path it will copy the file into a simple example. This it will create the new folder, and it will put here. And next is the publish part. It will publish, and final stage it will run the .NET run. You can see here ENTRYPOINT.NET run. So this is the example. If I run this, you can see here, you can see this option container Docker file. When I run, it will run the application. Currently you can see here, if I run this application, so it's run. You can see here when I open the container tab, you can see here the application is running inside the container. So this is how you can add a Docker file to your Visual Studio project. So you can see here, this is the same code, Docker file I created in the Visual Studio. So now we will discuss the different stage in detail. Like this is the multi-stage build. So the first stage is the base, the stage one is the best. You can see here it's a runtime. What is the purpose? Provide lightweight runtime environment, only the .NET runtime, not the SDK. So you can see here we separate the .NET runtime from the SDK. So it's a multi-build. So first is the base. And image usage, we are using the runtime image, contain just the N of .NET for the .NET application. And what is the user app UID? You can see here the second instruction. Run the container as a non-root user security. UID is expected to be set externally. So you can set this externally, the UID for the security purpose. And the other is the working the directory instruction. So we have set working directory where the app will run. So it will set the directory. So this is the first. The second is the build stage. You can see here the build stage is compile the application, image usage. We are using the SDK image that restore, build, and publish. And this is the steps like copy project from separate optimized Docker cache, restore, copy, and build command. And the third one is the publish, prepare the app for deployment, like .NET publish, and other instruction like use host, app host false. So you can see here, if I go to the publish is using the build configuration to release, and they have some instruction as well, like use app host equal to false, and it will use the .NET publish. And the final stage is the actual runtime container. Based on the base stage runtime only, no SDK, it will only use the runtime. Copy publish file from the publish stage into app, and set the setup command like .NET run .NET simple example.dll. You can see the final one, working directory app, and it will copy the file, and it will run the DLL. So this is the multi-stage build. I explain each stage in detail. And next, why we need multi-stage? If you build everything in one image, the final image could be include the SDK and build file, make it huge. The size will be huge, so which is not useful for production. So this approach, like the multi-stage approach, use the SDK image only for building, and use the runtime image for production, which is lightweight, faster, and safer. So this is the purpose. So I will recommend to use the multi-stage Docker file. Okay, so next is the building, how you can build the Docker file. So this is the build command, docker build slash then t sample app. So here is the explanation. The Docker file, the command to build an image from a Docker file, and the / specify the Docker file is in the current directory, and comma t simple example, take the new image to the name. We specify the name, and tag are used to name and version image. So this is the type of build command. We'll write docker build dash / t, and then you will give name. So when you click enter, it will start building. So you can see here the image is built. So this is how you can build your image. So this is the build command. And the next is all image name must be in lowercase. So you will follow this rule, like lowercase. You can also run this command like docker images, that will give you all the images list. For example, if I go here and run the docker images, it will give all the images. You can see here, this is the simple example, is the latest image I built. So this is about the images list. You can also check from the Docker desktop UI as well. Next, okay, next is how you can run. After building, you will run the Docker image. So this is the command, docker run -- name. You will give name to your container, first container, and this is the image name, simple example. So you can say this create and run a new container named firstly from the simple image. the program output, this program run in a Docker container will be displayed. So this is the run command. So for how we will run, like docker run dash, you will give name my first container, and this will be the image name, example container. So next we will see list container. There is two command like docker ps, it will list my running containers, and docker ps dash all, list all the container including those that have stopped. So let's see these two command. Okay, so first I will check the docker ps. So you can see here this is the current running, there is nothing. So let's write the other command, docker ps dash all. So you can see here one image is running, one container is running. This is the container id, the image name, the command, and created date, and this is the other information. So next we'll see restart and stop container. You can also restart, docker restart container name, this is the restart command, and here is the other removing and stopping container. You can run docker stop my container, you can run this command in PowerShell. And the other one is remove a container, remove an image from your local registry. So this is some other command you can use in your this is the text source tag and target image. This command attach a new tag to an existing image. Tag or alternative name for an image. Tagging is the first step to prepare an image for the pushing to registry. So this is when you want to push the image to registry, so you can use this by tagging name. Okay, so this is how you can like push and pull images. Like you will need to know the registry, like docker. You must use the tag like docker tag my image. You will push to that repository. It will attach a tag to that image when you visit the repository. So you can see here the tag. So you can also push to the first you will tag, and then you can push to the like Azure. If you have Azure ECR, you can push to that. So you can see first take and then push. Pulling an image, you can use this command docker pull register URL of the image. So this is how you can pull the image. Logging into registry, if you are using Azure, you can use AZ login. It will require username. If you successfully log in, you can use the login name, you can mention the registry name. So another thing is that like Visual Studio, if you are using Visual Studio, you can use Visual Studio provide the Docker support for your application. Like I already mentioned this, if you are in the Visual Studio and if you click on the solution add, then you can see here Docker support. So this is how Visual Studio provide you the facility to add a Docker file. And if you are creating new application, you can also add the Docker support as well. This is a new project. You will select type of your project, then you will give name to your project, and in this step they are asking enable Docker support. So this slide is about this information, Visual support for Docker. We'll see the important command practically. So this is my simple console application that will run. It will show me the message service is running at port 8080, and it will run after a 10-second delay. So let's see the output in the locally. You can see here it will check, it will run after 10-second delay. So it's running locally. So now we will run the same application inside Docker. So how we will do this, we already have a Docker file. You can see here this is our Docker file. So how we will run, you will open the PowerShell. So the first command which is to build. So how to build this image first. So first I will run the build command. Here you can see docker build my .NET app, and this will be from the local directory. So I will add the dot. So you can see here it will start building. So it's completed. So now I will go to the Docker desktop application. So here is no container. I will just check the image. So you can see here the image is created. but you can see here the tag is latest. So if you want a customized name, so how you will give the customize tag? So for this you will use this command, docker build dash t my .NET app, and here you will use the tag, for example v1-0 and the current directory, so it will use the customized tag. So now I will go back to the images, local images in my docker desktop. You can see here they use the customized tag name, so you can use this command to give the customized name. So you can see here image is created but it's not running. So next we will run the container. So before this there is also one other command. If you want to check the progress during building the image, so you can also use this command, docker build t then name my .NET app, and then you will use this progress equal to plain and current directory. So it will show you the progress beside building. So this is the three way you can use. And now how we will run the container. If I go, there is no running container, so I have image but did not run any container, created any container. So how I will do this? So I will use this command, docker run and the image name. So my image name is my .NET app. Okay, so it will run. So you can see here the application is running inside docker container. So for verification I will go to the app. So you can see here that the container is running. So you can see here the container is running, but it's a random with random name. So how we will give the customized name? So for this you will use I will stop container. Whenever you stop the container, it will change the state. You can see here it now stopped. So how you will give the customized name? So you will use docker run dash name, and then you will give the name to your container by my container, and this is my image name, my .NET app. So you can see when I run, it will run, but it will use the customized name. So you can see here the name is changed from any random to the custom name. So this is how you can run the app. So next I will add a tag, and then I will push the image to the GitHub repository. So first of all I will give a tag so to the image. So how you will give the tag? Because whenever you push the image to the Docker Hub, you will need tag to attach with the image. So you will use this command, docker tag, and then my .NET app, my .NET app, and then you will use the username of your GitHub account. For example, if I go to the this is my GitHub Docker Hub. Docker Hub repos list. You can see here is the repo list, and this is my username. So I will use this username with the tag. So I will use ENGR Abdullah. So this will be the then I will give the repository name, my docker.net app. Then I will use the the tag. For example, I will give latest. You can see here the tag is added. Now the next step is to push the image to the Docker. So first of all, if you are did not log into the Docker, so you will use this command, docker login. So you can see here it will try to log in to my account. So if you did not create account, you will create account in the Docker Hub. Once you log in, then this terminal will be automatically attached. Okay, now I will push my image to the Docker Hub. So this will be the command, docker push, then my username, and then my repository, my .NET app, and then the tag name, latest. So it is preparing, and it's pushing the image to the Docker Hub. It will take some time. Okay, so it's completed. Now I will verify. So I will just refresh the page. So you can see here the repository is created and the image is here in this repository. So this is the information. The tag name is latest, image type, and other information related to the tag, and the image management. So this is the image here. So this is how you can create and run and push image to the Docker Hub. I hope you will like this video. Thanks. See you in the next video.